Hello, and this time we're looking at perpendicular lines. Now the first thing I wanted to say is, what is a perpendicular line? Well, if you have a line, then something perpendicular means that you are at right angles to it. That's what perpendicular means. Parallel is where it's the same gradient, it goes in the same direction, they never meet, whereas perpendicular is kind of like as opposite to that as you can. If something has to meet, then the most sort of the biggest angle that they could meet at is 90 degrees. It could meet at a little angle, and then it would swing around to 90 as the biggest crossover you could get, and then it would start coming the other way and actually get smaller again, the angle between them. So perpendicular lines just mean the line at right angles. And if we've got a gradient of this slope, so you've worked out a gradient, maybe you've done rise over run, or maybe you've just been given the gradient, or you might have calculated it from the brackets with the equation. The gradient is y2 minus y1 over x2 minus x1. However, you've got that gradient. If you know the gradient of this line, and you want the gradient of the perpendicular line, then it's the negative reciprocal. What does that mean? So the gradient, let's say m dash for the perpendicular one, the gradient of this one is minus 1 over the gradient of the original line. So negative, make it negative, and if it's already negative, it will become positive, and then reciprocal means 1 divided by it. So if we look at the examples I've got on the side, let's just get rid of this. Find the gradient perpendicular to minus 5. Well, the negative reciprocal, negative of minus 5 is positive, and then 1 over 5, so this one is going to be 1 over 5. Whereas 4/5, if you do the reciprocal of a fraction, it actually flips it upside down. The negative of this fraction, well, it's positive, so the negative will make it minus, and then the reciprocal of a fraction flips it over, so minus 5/4. And that's it. You don't have to do anything more. If you've told the gradient, then the perpendicular is just the negative reciprocal. So if we're asked something like this, is the line joining these two coordinates perpendicular to the line joining these two? Well, we need to know the gradient of these pairs of lines, so this line, and we can use this formula, the change in the y value over the change in the x. Make sure that if you do the second y value take the first, you also do the second x take the first. If you do it the other way around, make sure you do it the other way around for x as well. They have to go the same way, otherwise you'll introduce a minus that shouldn't be there. So the gradient for the first one, so let's say m1, is 1 take away 5, which is minus 4, over minus 1 take away minus 2. So be careful, minus 1 take away minus 2 is actually a plus, because it's a double negative. So that is minus 4 over 1, or just minus 4. And m2, the second gradient, is going to be the y value take the y value, so 4 take 3 is 1, over, and 5 take 1 is 4, so it's 1 over 4. Okay, so we've done the difference in the y values divided by the difference in the x values. So, is the line joining this one perpendicular to this one? Well, in this case, yes, because the number minus 4, when you do the negative reciprocal, becomes 1/4. And because this is the negative reciprocal, they are the negative reciprocal of each other, that means that they must be perpendicular. So, yes, they are. And if you were asked that in an exam, you would write an extra little few words just to say yes, because one is the negative reciprocal of the other. And the last question, find the equation of the straight line perpendicular to this that passes through this point here. Well, there's two ways of doing this. It depends how you like to approach it. The first thing in both of them is to pick out the fact that the gradient is 5. So our gradient is going to be, for this, minus 1/5. Okay, because it has to be the negative gradient, because we want it perpendicular. So the first way is just to put this into y equals mx plus c. The general equation of a straight line, y equals mx plus c. And we now know the gradient. We only need to know the c and we're done. So y equals minus 1/5 x plus c. And because we know these two coordinates, this one coordinate, sorry, these two values, 2 and 7, we can substitute that in and solve for c. So we can say 7 equals minus 1/5 times 2, so minus 2/5 plus c. And then we can work out what the c value must be. C equals, well, 7, let's turn it into fifths, so 7 whole ones times 5 is going to be 35 fifths plus 2/5, because we're going to move it across the other side. C is 37 fifths. And so the answer is that y equals minus 1/5 x plus 37 fifths. The other way to do it, if you don't like that sort of solving, is to remember the formula y minus y1 equals m bracket x minus x1. And you can use this if you know the gradient and you know a coordinate, you just substitute everything in and rearrange it. So y minus 7 equals minus 1/5 x minus 2. And then if we expand this, we get y minus 7 equals minus x over 5, or minus 1/5 x, which is what we wrote out there. It's the same thing, but just written slightly differently. So minus 1/5 x plus 2, and that's 2/5, I should say, because we times it by 5. And then when we bring the 7 over, by adding it, it's just going to do the same thing. We're just going to add 2/5 and 35 fifths together and get the same answer. So it doesn't matter which way you do it. Just some people prefer to remember a formula and just substitute things in and rearrange it, or move it all around. And some people can cope with the idea of substituting in the values, solving for c, and then rewriting the y equals mx plus c. As always, if you have any questions, pop them into the comments below. Otherwise, ta-ra for now.